Welcome back, YouTube. So, in this video, we're going to be going over the product and quotient rules, as well as higher order derivatives. Okay, so first, we're going to start off with the product rule. It's actually pretty simple, but it's also very powerful. It allows us to finally take the derivatives of products. So, for example, say that we have y is equal to x cubed times e to the x. All right. Now, if we look at the formula, then we could see that how to take the derivative is you kind of, leave one function alone, and then you take the derivative of the other, and then you leave the other one alone, and then you take the derivative of the first one. So we're going to be applying that same process to this function, right? Y prime is equal to, well, we're going to apply the formula, so we're going to leave this one for now. We're going to have x cubed, and then we're going to take the derivative of the other one, right? And then, same thing. So, we take the derivative of x cubed, and then leave e to the x, right? Now, of course, remember from the last video, this is just e to the x. And then, remember from the power rule that the derivative of x cubed is just 3x squared. So we have 3x squared times e to the x, and this is our final answer. So a very simple process there. And the next thing we're going to learn is the quotient rule. Now, the quotient rule is a little bit more complicated. It almost looks like the product rule in the numerator. You can see there's kind of a resemblance, except this is a minus sign. And also there's a squared term in the denominator. So, we're just gonna, go into this blindly and see how it goes with this function right here. Now we have y is equal to s minus square root s over s squared. Obviously there's multiple ways to do this, right? We could simplify it, right? Because these are both powers of s. But, with other functions, we wouldn't be able to do that. So we're gonna just try to use the quotient rule here. Now, remember, we're going to... this one's actually more particular, right? Because it depends on the order. This one's a minus sign, so you can't flip it. It won't be the same answer. So you're actually gonna have to follow the certain order which is specified in this formula, right? We're gonna leave the denominator alone, right? We're gonna leave the denominator alone, and we're gonna put y prime there. So we're gonna leave the denominator alone, and we're gonna take the derivative of the numerator, right? And then we're going to subtract the opposite way around. So we're going to have s minus square root s times the derivative. Oh, sorry. I keep putting d over dx. I'm just so used to it. It's out of habit. I'm going to take the derivative of s squared. And then in the denominator, we just have g of x squared. So that's just going to be s squared squared, which is s to the fourth. All right, so let's simplify some of the terms. We're going to have, let's see, this is 1, and, derivative of this, that's just, I'm going to actually write it out. It's s to the 1/2. All right, and that, we're just going to keep going. So 2s over s to the fourth. Remember, from the power rule, we can evaluate this term. This just becomes 1/2 times s to the negative 1/2. Remember, we just subtract 1. I'm just going to move that over here. Okay, and then now we're going to distribute some of the terms in the numerator, just to simplify it a little. We get s squared minus 1/2 s to the 3 over 2 minus 2s squared plus 2s to the 3 over 2. A lot of different terms. Okay? Now, we're going to, let's see, we can condense some of these terms, right? We're going to get negative s squared, and then plus 1/2 times s to the 3 over 2. Oh, mistake there. just going to move this down. This should be 3 over 2. Right, yeah. Okay, and then over s to the 4th. And that simplifies to negative 1 over s squared plus 3/2 times 3/2 minus. So it's 1 over s to the 4 minus 3/2, which is negative 1 over s squared. Just trying to simplify it. 3 over 2 times s to the 5 over 2. So that is our final answer. It's a pretty complicated formula. Honestly, it's a lot more work than the product rule, but, you know, it's very powerful because it allows us to take the derivative of quotients. We weren't really able to do that before. So we're going to be seeing a lot of quotient rule coming up. But yeah. Okay. So now we're just going to go briefly over the higher order derivatives. It's actually not too difficult. Okay, so part A asks us to find f prime of x. I mean, this is just basic product rule, right? F prime of x is equal to 2x, right? Oh, sorry, I should probably. So d over dx of x squared times e to the x, right? Remember, we took the derivative of one and then left the other. And then we're going to take the derivative of the other one, e to the x, and leave the x squared. So this just gives us 2x, e to the x, plus e to the x times x squared. All right, so this is our f prime of x. Nothing too complicated there. All right, now f double prime of x. This is going to get a little bit more dicey, but, you know, nothing that we haven't really done before. First, we're going to take out, or we're going to separate the terms. So we get d over dx of, oh, sorry, I should probably write f double prime of x. F double prime of x is equal to derivative, or I can also take out the constant, 2 times derivative of x e to the x plus derivative of x squared e to the x. Now, this term, right, we're going to simplify that. Take the derivative of this one, that just becomes 1. I'm just going to go through this a little faster because it's a lot of work. And then we're going to take the derivative of the other, right, e to the x, and then leave this one. So we get plus x e to the x. If you would like, you could slow down, just try to evaluate everything. But for the purposes of this video, I want to just kind of get through everything. And we've already evaluated this, see, right? That was just our initial problem. So we could just copy down our answer from before. 2x e to the x plus e to the x squared. And this just gives us 2 e to the x plus 2x e to the x, 2x e to the x plus e to the x squared. We could simplify that. Right, that gives us 2e to the x plus 4x e to the x plus e to the x squared. All right, so this third derivative, it's going to be mostly same thing, right? I just wanted to introduce the concept of taking, you know, a lot of derivatives. I'm just going to move this further down so we have more space. Part C. So f triple prime of x. Notice that we denote the higher derivatives with this like type of putting in parentheses and then the number of the derivative we want to take. It's just to reduce the amount of space that we need, right? I mean, obviously putting prime, it's not going to work out. Okay, so this is actually pretty, you know, it's pretty easy actually because we've already taken most of these derivatives. So f triple prime of x, well, we're going to take the derivative of this one, that's 2e to the x, same thing, right? And then we have plus 4 times d over dx of this. Remember, the derivative of x e to the x, we've already done it, it's up here. So it's 4 times e to the x e to the x. And then we've already done this one as well, right? E to the x squared. That just gives 2x e to the x plus e to the x squared. All right. And now we evaluate it. Gives 4 e to the x plus 4x e to the x. 2, and then this one. So, simplifying all that out, we get this, right? So, not too complicated there, just a lot of computation. And you're going to see this as like a common theme where, you know, honestly, most of calculus is just a lot of algebra. Anyways, we're going to move on to some of these application problems of the rules that we've already learned. Okay, so it says, let P of x is equal to f of x times g of x, and q of x is equal to f of x over g of x, where f and g are functions. The graphs are, you know, shown below. Now, it's asking us to find p prime of 2 and q prime of j. Sorry, I'm just going to switch to a different pen color here. Okay, so we know that p prime, right, p prime of x, from the product rule, because we already know that p prime of x is right here, is equal to f prime of x times g of x plus g prime of x times f of x, right? And it's asking us to find p prime of 2. So we could just plug that in, right? We get f prime of 2 times g prime of 2 plus g prime of 2 times f of 2. Okay, so now our role is to kind of figure out all these values. Well, let's look at it, right? We have f prime of 2. Well, where is 2? 2 is right here. Now, remember that the derivative is the slope of the tangent line. But what is the slope of the tangent line at this point? Visually, it looks like, you know, it's a straight line. I mean, it looks like a parabola, so pretty clearly the slope of the tangent line that is going to be 0. So we know that f prime of 2 is going to be 0. And we don't even need to deal with this g of 2 term because, you know, this is 0, so it's all going to cancel out. Now, it's asking for now g prime of 2. All right, what is g prime of 2? Let's look at the graph. G prime of 2 is right here. And you could see, well, let's just label it. So 3, 2, 3, 4. You could see that the slope of the line goes up by 1 and right by 2. So the slope is going to be 1/2. That means g prime of 2 is 1/2. Because it's the slope of the tangent line, and obviously that's a straight line, so the slope is going to stay the same all throughout. So we know this right here is 1/2. And then it's asking for f of 2. Right, f of 2, let's see. F of 2 right here, it's 3, right? So we're going to put 3 there, times 3. That means p prime of 2 is going to be equal to 3 over 2. And that's just one part of our problem. Now, the other one, it's more of the same, right? We're going to go through that pretty quickly. Q of x from the quotient rule, Q prime of x from the quotient rule is going to be g prime. All right, we could refer to our formula over there. It's going to be g of x and then derivative of the first one minus f of x times derivative of the second one. So we could just, you know, copy down that formula. Right, we take the derivative of the first one. Yeah, I could just write f prime of x. Yeah, sorry. F prime of x times g of x. And then minus g prime of x times f of x. Over g of x squared. Remember, we got to be careful with that order. You know, I've screwed up many problems because I swapped the order. And it's asking for q prime of 7. So, you know, we're going to be looking for x values of 7 here. Or f prime of 7 times g prime of 7 minus g... sorry, not prime. G of 7. Okay. And then g of 7 squared. Alright, so nothing too complicated here. So let's look for it, right? I'm going to label out the graph so we actually know where is the value of 7. 7's right here. 4, 5. Okay, so the slope, right, we could see is goes up by 1, right, by 4, so the slope is 1/4 for f prime of 7. F prime of 7 is equal to 1/4. G of 7, what is G of 7? G of 7 is right here, looks to be about 1, so we're going to put G of 7 is equal to 1. And then G prime of 7, let's see, right, we have a point right here and a point right here. The slope of that tangent line is going to be, well, it's right here, so it's just going to be the slope of this line. And the slope of that line is go down by 2 and right by 3. So it's going to be negative 2/3. And finally, f of 7, it's just going to be right here, that's 5. And now we just know all of our values, we can just plug them in, right? F prime of 7 is 1/4, G prime of 7 is 1, or G of 7 is 1, G prime of 7 is negative 2/3, and then f of 7 is 5, over negative, it's over just 1 squared, which is 1. You get 1/4 plus 2/3, and then times 5, which is 10/3. And the 1 is obviously doesn't mean anything. So we could simplify that. It's 3/12 plus 40/12, which gives 43/12, and that's our answer. Okay, so graph problems. To summarize, just look for the, well, first you could simplify it, and then just look for each of the values using the graph and your intuition. This one, we've already went over how to find the equation of the tangent line, so I don't think I'm going to be doing this one in today's lecture, but just to summarize what we did in the previous videos, you first need to find that slope. Find the slope at the tangent line, or sorry, the x value at for the tangent line. So find the slope at the x value for the tangent line, right? That gives you the slope of the tangent line, and then you could use this point right here, use the point to write out equation in point slope form. You could try that as an exercise. I have a problem like that in the comprehension question, so you can also do that. So pretty simple there. It's nothing too complicated, just using the stuff that we already learned and the stuff from previous lectures. Okay, so finally we're on to our comprehension questions. These are questions where you should try for yourself, just using the stuff from today's lecture and the previous ones. This one, I have to warn you, it's a lot of work. More work than the other ones, at least. But, yeah. I'll post the answers in the description. And anyways, that'll be it for this video. Try them by yourself. And let's do some more math in the next video. See ya.